Hi everyone, welcome to Winpoint online classes. Today we are going to discuss some of the important questions from the chapter Magnetism. Important questions and answers set 2. First question. Which of the following correctly describes the magnetic field near a long straight wire? Before reading the option, you can think about the answer. Long straight wire, around it there will be circular magnetic field, and that circular magnetic fields are concentric circles, right? These circles are concentric, small one, big one, and bigger one, like that. So it is concentric. So these are concentric circles. Now we can read the option. The field consists of straight lines perpendicular to the wire. Wrong option. The field consists of straight lines parallel to the wire. Wrong answer. The field consists of radial lines originating from the wire. Wrong answer. The field consists of concentric circle centered on the wire. So that is a right answer. The field consists of concentric circles centered on the wire. Next question. The phenomenon of electromagnetic induction is, so it is a definition for the electromagnetic induction. You need to, before reading option, you need to think about the answer. What is electromagnetic induction? If there is a change in magnetic field, there will be production of electricity. Now let's read the options. The process of charging a body. Wrong option. The process of generating magnetic field due to current passing through a coil. It is generating magnetic field. No, we are generating electricity. Producing induced current in a coil due to relative motion between magnet and the coil. Yes, we are producing electricity with the help of movement of magnet or coil. That's the right answer. Producing induced current in a coil due to relative motion between magnet and the coil. Next question. Device used to produce electricity is, we can produce electricity using generator. So answer is generator. The essential difference between AC generator and a DC generator is that generator is having slip rings and DC generator is having split rings. That is also one of the difference. AC generator has an electromagnet while a DC generator has permanent magnet. DC generator will generate a higher voltage. AC generator will generate a higher voltage. No, these are wrong option. The last one. AC generator has slip rings while DC generator has commutator, means split rings. Commutator means split rings. That is answer. AC generator has slip rings while DC generator has commutator. At the time of short circuit, the current in the circuit. What is short circuit? If the neutral wire and the live wire is touching each other, there will be overflow. There will be flow of current, excess amount of current. That is short circuit. Now we can go for the option. Reduces substantially, does not change, increases heavily, vary continuously. Increases heavily. Answer is increases heavily. There will be increase in the current. State whether the following statements are true or false. First one. An electric motor converts mechanical energy into electrical energy. Electric motor is converting electric energy to mechanical energy. Motor is working and we are using that energy. In the case of generator, the generator is working. Here we are giving electricity, we are supplying electricity, and motor is working. We are using that mechanical energy. So it is a false statement. An electric generator works on the principle of electromagnetic induction. True statement. It is a right statement. True. The field at the center of long circular coil carrying current will be parallel straight lines. Yes, when we are considering a long circular coil, at the center it will be looking like a straight line because the concentric circles will be very big. So it will be part of that circle, but it will be a large circle. Because of that, we will feel it's a straight line and these lines are parallel to each other. So it is true statement. The wire with a green insulation is usually the live wire of an electric supply. Green wire is earth wire, red wire is live wire, black wire is neutral wire. So it's a false statement. Green wire is earth wire, not live wire. List 3 sources of magnetic field. It is a solenoid, and inside the solenoid you can see a iron rod. Electromagnet. Electromagnet is a source of magnetic field. So first one is electromagnet. Next one, here you can see that current carrying conductor. Current carrying conductor is a good source of magnetic field. There will be production of circular magnetic field lines around current carrying conductor. Next one is bar magnet. Bar magnet is also source of magnetic field. So these are the three sources of magnetic fields: electromagnets, current carrying conductor, permanent magnet. How does a solenoid behave like a magnet? Can you determine the north and south poles of a current carrying solenoid with the help of bar magnet? Explain. When we are transmitting electricity through a solenoid, it will be acting as a magnet. It will be acting as a bar magnet. Here you can see the solenoid. This side is north pole and that side is south pole. When we are placing a bar magnet here, we are going to place a bar magnet here. When we are placing a bar magnet here, it's a north pole, right? The white dot indicates north pole. When we are introducing this north pole to the solenoid, if there is a repulsion, we can say that that end is north pole. If there is an attraction, that end is south pole. So here you can mark it is north pole and south pole because of the repulsion. The magnetic field produced by a current carrying solenoid is similar to the magnetic field produced by a bar magnet. We can determine the north pole and south pole of current carrying solenoid with the help of bar magnet. The north pole of a bar magnet is brought near to the both ends of the current carrying solenoid. The end of solenoid which repels north pole of the magnet is north pole of the solenoid. The end of solenoid which attracts north pole of the magnet is south pole of the solenoid. When is the force experienced by the current carrying conductor placed in the magnetic field largest? We know that when we are placing a current carrying conductor in a magnetic field, there will be force. The force will be maximum when magnetic field lines and electric field lines are perpendicular to each other. If the direction of current is perpendicular to the direction of magnetic field, then the force will be maximum. Next question. Imagine that you are sitting in a chamber with your back to one wall. An electron beam moving horizontally from the back wall towards the front wall is deflected by a strong magnetic field to your right side. What is the direction of magnetic field? Here it's given that we are sitting at a place and there is a electron beam from the back wall to the front wall, and that electron beam, the electron is deflecting towards your right. I am talking about my right. Okay, so it is deflecting towards right. We need to find the direction of magnetic field. How we can find the direction of magnetic field? Yes, we can use Fleming's left hand rule. So we are going to use Fleming's left hand rule. According to this rule, forefinger is indicating the direction of magnetic field, middle finger is indicating the direction of current, and thumb is indicating the direction of force. Here the direction of force it's given. It is a direction of force towards right because it is deflecting towards right. I am talking about my right. And the electron beam is coming from the back wall to the front wall. It is the direction of electron beam. So what will be the direction of current? It will be opposite, right? The direction of current will be from front wall to back wall. It will be opposite to the flow of electron. So it is the direction of current. Okay, this is the direction of current. What is the direction of magnetic field? Downwards, right? You need to hold your finger like this, then only you will get the answer. Force, current, magnetic field. Magnetic field is in downward direction. Next question. Name some devices in which electric motors are used. We are using lots of devices at home, right? Like fan, mixer, grinder, washing machine, and all these electronic devices are application of electric motor. So we are going to name some devices: fan, mixers, coolers, and washing machines. A coil of insulated copper wire is connected to a galvanometer. What will happen if a bar magnet is pushed into the coil? Second one, withdrawn from inside the coil. Third one, held stationary inside the coil. This question is from electromagnetic induction. We have to know about electromagnetic induction. What is electromagnetic induction? If there is a change in magnetic field, there will be production of electricity. That is called electromagnetic induction. Let's do it now. It is a coil and there is a galvanometer, and we are considering a magnet here. It is a magnet. Magnet is having north pole and south pole. Now the magnet is not moving, so there is no electricity. If the magnet is not moving, there is no electricity. When we are moving this magnet towards the coil, we are going to move this magnet into the coil. When we are moving that magnet into the coil, you need to observe the deflection. Here the deflection is opposite to the movement, right? So there is a production of electricity. That is the reason for this deflection, and the direction of this electricity is opposite to the movement of the magnet. Now the magnet is not moving, it is at stationary position. So what is going to happen? There is no change in magnetic field. It will come back to the same position. Your galvanometer is giving a reading of 0. Now we are going to take the magnet outside. What is going to happen? Can you guess the answer? When we are taking the magnet out, there will be deflection. This deflection will be opposite to the movement of the magnet. Magnet is pushed into the coil. The needle of the galvanometer shows a deflection in a particular direction. Second one, withdrawn from inside the coil. Answer is the needle of the galvanometer shows a deflection in opposite direction. Third one, held stationary inside the coil. There is no deflection when we are keeping the magnet inside the coil stationary. There is no deflection, there is no electricity, zero deflection. Two circular coils A and B are placed close to each other. If there are two coils and these coils are close to each other, means the question is from mutual induction. If the current in the coil A is changed, will some current be induced in the coil B? Give reason. Yes, there will be induced current. This phenomenon is known as mutual induction. A current is induced in the coil B due to a change of current in coil A. This phenomenon is known as mutual induction. If you have any doubt in mutual induction, you can click on the link given above. You can learn that again. State the rule to determine the direction of a magnetic field produced around a straight conductor carrying current. Second one, force experienced by a current carrying straight conductor placed in a magnetic field which is perpendicular to it. And third one, current induced in a coil due to its rotation in a magnetic field. There are three rules. First one, to find the direction of magnetic field around a current carrying conductor, thumb rule, right hand thumb rule, right? Next one, force experienced by a current carrying conductor placed in a magnetic field, Fleming's left hand rule. And direction of current induced in a coil due to its rotation of magnetic field, Fleming's right hand rule. When does an electric short circuit occur? There are three wires, earth wire, neutral wire and live wire. If there is a direct contact between live wire and neutral wire, then we can say that there is a short circuit. These are two wires, live wire and neutral wire. If there is a direct contact between neutral wire and live wire, then it is known as short circuit. So here there is a contact between live wire and neutral wire, so it is short circuit. If a neutral wire and live wire are coming in direct contact because of insulation problems, then it is called short circuit. What is the function of an earth wire? Why is it necessary to earth metallic appliances? This earth wire is for our protection. For example, if we are using an electronic device and sometimes there would be insulation problems. Because of this insulation problem, the electricity will flow on the surface of the metal. This is very dangerous. There should be an earth wire which is connected to this metallic surface. Then the electricity will flow through the earth wire to the earth. This is for our protection. This is the function of earth wire. If you have any doubt in the working of earth wire, you can click on the link above, then you can learn that. Earth wire is connected to the metallic part of the electronic devices. If there is any leakage of current because of insulation problems, this current will flow to the earth directly. This will protect the user from electric shock.